Hello, guys. Welcome again to our, electric circuit course. In this lecture or video, we're gonna explore, or continue basically our discussion about mesh current method. So we take two videos so far. One for a circuit to solve with mesh current method with no current source. The other video how to solve with the presence of uh, uh, an independent current source. And this video, we're gonna see how to solve with a dependent current source. Okay. So we have here in this circuit, for example, a dependent current source. So this current source depend on the voltage across, the resistor R2, 2 ohms here, and in that direction from negative to positive. So basically, what we're gonna do is to follow the same procedure we studied, in the last video on how to solve with the presence of a current source. Okay, so basically, no change. Okay, again, the two principles. If you have a mesh with a current source, this mesh will give you the current represent this mesh, as we're gonna see right in a moment or so. And if you have the current source in a shared branch, then basically you can't apply, directly the mesh current method to that mesh, and it has to be a loop because you have to avoid this, this branch, because basically, again, we cannot know the voltage across the current source. We know the current across the branch, but we don't know the voltage across the branch. And we remember the mesh current method depend on Kirchhoff voltage law. So we need to build equations, by balancing the voltages. Okay, good. So we have here a dependent current source. Ix is equal to 4V1. V1 is the voltage across the resistor 2 ohm. We have three meshes. So let's assume this is mesh I1, this is mesh I2, and this is mesh I3. And remember here the dependent current source is a non-shared branch, so you can put a mesh here. It's okay. Okay, good. So we have three meshes, so we should have like three equations, for example. Okay, and remember, the beauty of the presence of a current source, it can give you one of the unknowns. Okay, although it's indirectly here because it's a dependent, but at least it will give you an equation. So remember that, in mesh current method, the currents that represent each mesh is the current that flows in the non-shared branch. So in mesh I1, here is I1 actually. The actual branch of I1 is this one, which is a branch that has the voltage or the battery 10 volt. I2 flows basically in the resistance 3 ohm. And I3 is basically the same current as the branch current or the branch current source, which is Ix. Okay, and that's basically the equation. So Ix from mesh 3, I3 equal to Ix. Okay, Ix going in that way, basically same way or same rotation of I3. So I3 is equal to X. So I3 is also equal to 4V1. 4V1. How to find V1? So let's go to this node here. So in that node here, I1 is going out, I2 is going in, and let's assume the current, let's call it I, for example, is going downward. So at that node, the current that is going out, which is I1, equal to the summation of the current that is going in, which is I plus I2. So let's write this equation here. So I1 equal to I plus I2. So what is I? I is the current flowing in the resistance 2 ohm. So I equal to the voltage across the resistance, which is V1, divided by the resistance, which is 2 ohm, plus I2. So let's multiply all sides by 2. So 2I1 equal to V1 plus 2I2. So V1 is equal to 2I1 minus 2I2. This is very important. Very important. Because now we can write I3 in terms of I1 and I2. So I3, which is equal to 4V1, will be equal to 8I1 minus 8I2. Or basically 4 multiplied by 2I1 minus 2I2. So just distribute the 4 on the 2's. So 4 by 2, 8, 4 by 2, 8. So 8I1 minus 2I2. Good. So that's the equation that the current source will provide for us. Okay, let's call it 1, for example. Now let's go to mesh represented by I1. So I1 mesh. Just apply the current, the mesh current method normally. So I1 multiplied by the summation of the resistances in that mesh, which is 1 ohm plus 2 ohms, minus I2 multiplied by the shared resistance between mesh 1 and mesh 2, which is 2. So 2 I2 minus I3 multiplied by the resistance in the common branch or the shared branch between mesh I1 and mesh I3, which is 1 ohm. So 1 multiplied by I3 equal to the summation of voltage sources, or the voltage sources that you have here just 1, and the current is flowing in the same direction of the current going out of the battery. So basically it is positive, so equal to 10. Let's simplify it. So 3I1 minus 2I2 minus I3. 1 multiplied by I3 is I3. Let's remove I3 and put its value. 8I1 minus 8I2. Remember, there is a minus before that, so it will be minus 8I1 but plus 8I2, because minus is plus, equal to 10. So let's have common factors here, or simplify more. So we have 3I1 and the minus 8I1. This is minus 5I1. We have minus 2I2 and plus 8I2. So this is plus 6I2 equal to 10. Call it 2. Equation 2. Now let's take equation of mesh I2. Again, same principle, but just to keep the order, I'm gonna write I1 first. So, or we can start by I2. So I2 multiplied by the summation of the resistance in mesh I2. So I2 multiplied by 1 plus 2 plus 3. So I2 multiplied by 1 plus 2 plus 3, because we have resistance 1, a resistance 2, a resistance 3. Minus I1 multiplied by the common resistance between mesh 1 and mesh 2, which is 2. So multiplied by 2. Minus I3 multiplied by the common resistance, which is I1. So 1 ohm. So 1 I3 equal to 0, because there is no voltage sources or batteries here in mesh 2. Again, simplify it. So minus 2 I1 plus, this is 6 I2. And let's remove I3. Well, of course, 1 I3 is just I3. So let's remove I3 and put its value, which is 8 I1 and minus 8 I2. Remember, there is a minus here. So it will be minus I1 plus 8 I2. Minus 8 I1 plus 8 I2 equal to 0. So we have minus 2 I1 and the minus 8 I1. This is minus 10 I1. We have 6 I2 plus 8 I2. This is 14 I2 equal to 0. Good. Call this number 3. Let's multiply number 1. Remember, we have now 2 equations in 2 unknowns. We have equation 2 in I1 and I2, and equation 3 in I1 and I2. These are 2 equations in 2 unknown, I1 and I2. Let's multiply equation 2 by minus 2, all sides. So minus 2 multiplied by minus 5 will be 10. So 10 I1. Minus 2 multiplied by 6 will be minus 12 I2. Minus 2 multiplied by 10 will be minus 20. And call this number 4, which is derivative from number 2. Let's now add equation 3 and equation 4 together. If we add them, this guy will cancel this guy. We have here 14 minus 12 will be plus 2 I2. We have 0 minus 20 will be minus 20. So from that here, I2 is equal to minus 10. Now we choose any equation and just compensate to find I1. So let's do the first one here. So minus 5 I1. Then plus 6 I2. So plus 6 multiplied by I2, which is 10, equal to 10. So minus 5 I1 minus 60 equal to 10. So minus 5 I1 equal to 70. So from that, I1 will be equal to 70 divided by minus 5. This is actually minus 14. Minus 14 amperes. So I1 is equal to minus 14. So we get I2 and I1. So now let's find Ix. Actually, the question was finding Ix. Find Ix, this branch or this like dependent current source voltage. So Ix is equal to 4V1. Ix is equal to 4V1. So what is V1? V1 we just found it basically at the beginning. V1 is 2I1 minus 2I2. 2I1 minus 2I2. Minus 2I1 minus 2I2. 2I1 minus 2I2. So equal to 4. Multiplied by 2. We can take 2 as a common factor. I1 is minus 14. I2 is minus 10. Minus minus will be positive. So that's actually 8 multiplied by minus 4. So Ix equal to minus 32 amperes. That's basically what we want. Okay, guys, that was our journey with the mesh current method. Thank you very much for watching and see you in another video. Bye-bye.